Hello and welcome to another algebra lesson. Before we get started with today's lesson, please make sure to complete the warm-up to review our previous lesson. What we're doing is identifying whether each relation is a function or not. So go ahead and pause this video as you complete these. Once you're done, you can hit play. I'll go over the answers quickly and then we'll get started with the lesson. All right, so at this point you should have completed the warm-up. The answers are yes, the first one is a function. Now you'll notice that the input repeats 3 and 3, but because the output is also the same, it is still a function. For the second one, yes, it is a function because any vertical line that we draw through that graph only hits the graph once. And then the third one, that last one bottom right, is not a function because there is a line that exists, a vertical line that exists that hits the graph more than once, which makes it not a function. So today we're going to talk about rate of change. So our essential questions are, how can constant rates of change be used to solve problems? And how can parts of lines be interpreted in context? So if I'm ever going too quickly for you as you're working through the notes, again, remember you can just pause the video until you get caught up and then hit play and keep going. So some vocab to get us started. A solution of an equation. A solution is an ordered pair, x and y, that makes the equation true. So an ordered pair is found on the graph of the equation if we were to graph it. For example, is 1, 3 a solution of the equation y equals 4x minus 1? Well, what we would want to do first is plug in those coordinates 1 and 3 into our equation. So where do they go? Well, x is 1 and 3 is our y coordinate. So we would just replace x and y with 3 and 1. So 3 is replacing y and 1 is replacing x. So we get 3 equals 4 times 1 minus 1. Simplifying that, we get 3 equals 4 minus 1. And since 4 minus 1 is 3, we get 3 equals 3. So that is a true statement. 3 does equal 3. That checks out. So because of that, that has created a solution. That's created a true statement, so the coordinate 1, 3 is a solution. If your final step is untrue, if that statement was not true, like 3 equals 7, not true, then the point would not be considered a solution. So your turn. Are the given points solutions to the following equation? So is the point 1, 2 a solution to x plus 3y equals 6? How about the ordered pair 3, 3? Is that a solution? So pause the video, go ahead and work that out and determine whether each of those is a solution or not. Once you're done, go ahead and hit play. We'll go over the answers and continue on. At this point, you should have completed your turn number 1. So as it turns out, neither of these are solutions because we get statements that are not true. 7 does not equal 6 when we plug in 1 and 2 for x and y. We get 7 equals 6, not true. And then when we plug in 3 for x and 3 for y, we get 12 is equal to 6, which again is not true. So neither of those are solutions to the equation. So what about a graph? Given the line, or the given line represents the graph of x plus 3y equals 6. So we want to use the graph to determine if either of these points, ordered pairs, is a solution. So the ordered pair 1, 2, if we plot that on a graph, remember x comes first, y is second. So x, we go to the right, our y axis is vertical. So 1, 2, we go right 1, up 2. So there's 1, 2, that is above our graph. So that is not a solution because it's not on the line. Negative 3, 3, that would be left 3, up 3. Hey, that point is on the line. So that checks out. So we would say that yes, Negative 3, 3 is a solution. So self-quiz number 1, you are determining if the following points are solutions. So using 1, 5, plug that in. Is it a solution? How about negative 4, 0?